Okay, so in this lesson here, we learned how to tell if there were real zeros or complex zeros. So this next one that we're going to be looking at is going to be specifically looking at the real zeros and telling if they are positive or if they are negative. So the first thing that we need to do when working with this is we need to define what a variation is. Okay, so a variation is going to be anytime there's a change between a plus or a minus sign in a real polynomial function. And that will be when there are two consecutive coefficients that have opposite signs. Okay, so if we look at this example here, 2x to the fifth power minus 7x to the 4. That is a positive 2 and a negative 7. So there is a variation in that there. Then I have a negative 7x to the fourth plus a 3x squared. There is a variation. That is a negative to a positive. Next, I have a positive 3x squared to a positive 6x. There's no variation. They are both plus signs. Okay, and then the next thing I have here is your positive 6x minus 5. There is a variation there. Okay, so that each of those will be your variations. Okay, so this function would have three variations. Now, specific notation. V positive, that's the variations for f of x. Okay, that's going to tell us how many positive real zeros we have. The next one is V negative. Now, V negative is going to be that you have substituted in a negative x there. The negative is going to tell you the number of negative real zeros that this has. Okay, so let's go ahead and practice some with that. Okay, actually, before we practice, I have to define this. I guess I forgot. So V positive is the number of positive real zeros. Okay, now my possibility, say I could have 4 positive real zeros. My V positive was 4. Okay. My options then for this would be 4. My next option would be 4 minus 2, which would be 2. My next option would be V positive minus 4, which would be 0. So if my V positive is 4, I could have 4, 2, or 0 real zeros. We follow that same pattern here with V negative. Say my V negative was 3. Okay, if my V negative was 3, then I could have 3. I could also have 3 minus 2, which would be 1. I can't go any further than that because then I would get to negatives, and that's not possible to have our negatives there. So if my V negative was 3, I could have 3 or 1 negative real zeros. Now, why do you guys think that we are subtracting by 2? That is because, again, your complex solutions come in pairs. So your complex solutions always have to be even. So when we're coming up with all these different possibilities, okay, that's why we are moving down by 2. Okay? All right. So now we're ready to practice. Okay. How many real zeros are positive? How many are negative? Okay. So starting out, what is my V positive? Well, I'm going to count my variations. Okay. Count my variations in f of x. Okay. Positive to negative, negative to positive, positive to positive, positive to negative. So my V positive here is 3. Okay. Now, since my V positive is 3, that means I can have 3 or 1 positive real zeros. Okay. Next, we're going to look to V negative. Before I can do V negative, I need to plug in a negative x for each of these values. So 2x to the fifth minus 7x to the fourth plus 3x squared plus 6x minus 5. But instead of x's, I have a negative x in each of these spots here. Now, you guys will find as you're doing this, okay, if I have a negative with an odd exponent, that odd exponent will not get rid of that negative. So it ends up changing the sign. Instead of it being a positive 2x to the fifth, it's now a negative 2x to the fifth because the exponent that was odd did not get rid of the negative sign. Versus if I have an exponent that's even, like negative x to the fourth, that even exponent will get rid of the negative. So my sign will stay the same. Okay, so I had a negative 7x to the fourth. That even exponent gets rid of the negative, so it stays as a negative 7x to the fourth. Okay. Next one, I've got an even exponent. It's not going to change the sign, so it's a positive 3x squared. Positive 6, negative x, that would change the sign, and then I have my negative 5. So my v negative will be looking at how many variations I have now in f of negative x. So negative to negative, nope. Negative to positive, yep. Positive to negative, yep. Negative to negative, nope. My v negative is 2. Now what does that mean? That means I can have 2 or 0, okay, because we always move down by 2, 2 or 0, negative real zeros. 2 or 0, negative real zeros. Okay? Now, the last thing that we have to do to create our answers for this, excuse me, we're going to make a chart for all of our possible outcomes. Okay? So when you make your chart, you have your degree. What is the degree of this equation here? You have your positive real zeros, you have your negative real zeros, and you have your complex or your imaginary real zeros. Okay? And we're going to make a chart based off this here. Okay? Now, what we did in the past was, on that last video, this was a degree 5. We had real and we had complex for degree 5. I could have 5 real, no complex. Then I moved down by even, so I could have 3 real, 2 complex, 1 real, 4 complex. What we're doing now is now we are shifting and we are splitting this real number column up. And instead of 5, I'm saying, hey, I could have 3 or I could have 2, 3 positive, 2 negative. Okay, so we're going to kind of play around with how that works there. So starting out with, I have 3 or 1 positive real zeros. My degree for this is a degree 5. So n is 5. That means that every single one of these numbers in the row need to add up to give me 5. So I usually, when I do this, I start out with a maximum value of real positives. So I could have 3 positives, and then I'll use my maximum for my negatives. I could have 2 negatives, okay? So if I had 3 positive reals and 2 negative reals, how many complex would I have then? Well, that would be 0 because I need all 3 of those numbers to add up, okay? Now, I'm going to look again. I'm going to go back. I have 3 positive, okay? I've already done 3 positive and 2 negative, but there's another option. I could have 0 negative. So I could have 3 positive and 0 negative. If that's the case, how many complex solutions would I have to add up to equal 5? Well, I would need 2 complex solutions, okay? Now, I go back to my 3. Are there any other possibilities? Well, I've done 3 and 2. I've done 3 and 0. So there are no possibilities for my 3. So now I'm going to move down to my 1, okay? So I could have 1 positive and then go back to my maximum, which would be 2. I could have 1 positive and 2 negative. Now, if I had 1 positive and 2 negative, how many complex would I need to have? The answer would be 2, because 1 plus 2 plus 2 gives me my 5. Okay? I'm going to have one more here. Whoops. Because I'm still at 1, and my other possibility is I could have 1 positive and no negative. So 1 positive and 0 negatives. What would my complex be? Well, the answer there would be 4. This chart is what we are creating today. Okay? What we will do next time is we will figure out which of these rows is actually the case. Okay? So basically you have your function here. Do I have a function that has 1 positive real 0 and 4 complex? So it could look like this. It's only got 1 positive real 0, and then it doesn't have any other ones because we can't see the complex on the real number line. Okay? Or is it something that has 3 positive? So we could go, whoops, have my eraser on. So we could go 1, 2, 3, 1, 2. So I had the top row here, say I have 2 negatives and 3 positives. Okay? So all you're doing right now is you're just creating the chart for all of the possibilities for what could be. Next time we will go over how to do or figure out which one is which. Okay, so we've got some examples that we are going to practice here. Okay, and then you guys will be done.